Okay, in this video we're going to go through this classic example where we have a malfunctioning alarm clock. Okay, so instead of using just one alarm clock, we're going to use three. Right, the idea if one doesn't go off, then maybe another one would. So that's what we want to know. We want to know, well, what's the probability of at least one, right? If at least one alarm clock works, then you wake up, right? So at least one alarm clock works. What's the probability that at least one works? And if the probability that each individual alarm clock has an 87% chance of working. Okay, so I'm gonna go ahead and use E1 as the event that the first alarm clock works. Okay, so this would be the event that the first alarm clock works. I'm going to write that. First clock works. Okay, and then E2 and E3, these would be the event that the second alarm clock works and the event that the third alarm clock works. All right, and so we know the probability that the first alarm clock works is 0.87, right? So the probability that each individual alarm clock works is 87%, or in other words, the probability is 0.87. So for each of these, the probability that it works is 0.87. All right, so now what do I want to know? I want to know the probability that at least one works. All right, so whenever you see the words at least one, all right, you should always consider the complement, right? The complement of at least one is none. Okay, and a lot of times it's easier to compute the complement than it is to compute, so at least one, that would mean maybe that the first one works and these ones don't, or that the second one works and the other two don't, or that the third one works and these don't, or that they all three work, or that, the first two work and this one doesn't. I mean, you could list off so many different ways we could get at least one working, right? So a lot of times it's a lot easier to not think about that list because it's so convoluted and difficult to think through. The easier way is to just think of the complement, which would be that none work. Right? The only way that you don't have at least one working is if none work. All right? So at least one, the complement of that is always none. All right? So this means that the opposite of event one, right? Sometimes we use the bar over top to note that. So E1 working would be E1 is the event that it works, so E1 bar, it means it does not work. Okay, so it does not work, and the second one does not work, and the third one does not work, right? That'd be none working, right? Okay, so how am I going to compute this probability? So the probability the first one does not work, and the second one does not work, and the third one does not work. Well, let's see. These are all independent events, right? Because what one alarm clock does has no influence on what the other alarm clocks do. So I could compute this like this. I could just use the multiplication rule. These are all independent events. So I could just multiply them by each other. All right. So now let's go ahead and put in each of these probabilities. So let's see, what is the probability of it not working? So that'd be 1 minus 0.87, right? So the probability of not working is 0.13. Okay, and it's going to be the same, 0.13, 0.13, so I can just do this to the third power. All right, so let's see, what is 0.13 raised to the third power? 0.002 197. All right, so do 1 minus that, and you get 0.997. Okay, this is the last step, so let's see, they said round to 4 decimal places, so 0.9978. That's good enough. All right, so the probability that at least one alarm clock is going to work and that the student will show up to her class on time is pretty good. So setting 3 alarm clocks was a good idea, considering the fact that all these alarm clocks potentially are flawed, right? It raised the probability of her arriving on time pretty high.